Next problem, based on random variable. So PDF of random variable, PDF of random variable x is given as fx of x is equal to e raised to minus x for x greater than equal to 0. So find mean e of x, second mean square e of x square, third one variance, and fourth one standard derivation. So this problem was asked in exam for 8 marks. Standard derivation. So here we have to find first the mean, so here first we have to find mean. So e of x is equal to mx, which is equal to integration minus infinity to infinity x fx of x dx. So it is equal to 0 to infinity x e raised to minus x dx. So it is equal to 1 factorial by 1 raised to 1 plus 1. So it is equal to 1. E of x square 0 to infinity x square e raised to minus ax dx. So it is equal to 2 factorial by 1 raised to 2 plus 1. So it is 2. Now we have to find then variance. So variance is calculated as sigma square is equal to e of x square minus mx square. So 2 square minus 1, it is 3. Next, standard deviation. Standard deviation. So sigma is equal to square. So it is 1.73. Next, random variable x is, next problem, random variable x is fx of x is equal to 5x square. So it is 0 else. So find e of x, e of 3x minus 2 and e of x square. So we have to find all these values. The problem was asked for 6 marks. So first, what is given? Given is that fx of x is equal to 5x square. So this is for, otherwise this value is 0. So first we have to find the mean value. So mean value is e of x. So e of x is equal to integration minus infinity to infinity x into fx of x dx, which is equal to 0 to 1 x into 5x square into dx. So 5 is constant outside, this is it becomes x cube. Integration of x cube is x raised to 4 by 4. Integration value is 0 to 1. So 5 by 4 is constant, x raised to 4, so it becomes 1 minus 0, that is 5 by 4. Now next we have to find the value of e of 3x minus 2. So the e of 3x minus 2, this value is 5 into 3x minus 2 square. So we have to solve it. It is 5 into 9x square minus 12x plus 4. So it becomes 945x square minus 12x plus 4. Now we have to take the integration. So integration from 0 to 1, 45x square minus 12x plus 4 into x dx. Now we take separate integration. So 45x square into x dx. 45 is constant, so x square into x is x cube. Integration of x cube is x raised to 4 by 4. Integration goes from 0 to 1. Minus 12 is constant, x into x square integration is x cube by 3, 0 to 1, plus 4 into integration of x is x square by 2, 0 to 1. So it is 45 by 4 and its value is 1, minus 12 by 3, value is 1, plus 4 by 2, it is 1. So it becomes 45 by 4 minus 4 plus 2. So we have to solve it. Denominator same, 45 minus 16 plus 8. So the answer is 37 by 4, e of 3x minus 2. Next we have to find e of x square. So e of x square is calculated as integration minus infinity to infinity x square fx of x into dx. So this is standard equation. Now we have to substitute here values. Integration goes from 0 to 1. Limits are given. Okay. Now x square, what is fx of x? It is given 5x square into dx. So 5 is constant, 0 to 1 x raised to 4 dx. So 5, x raised to 4 integration is x raised to 5 by 5, 0 to 1. So 5 get cancelled 1, and if we replace these values here, then it becomes, so 1 is the answer. So in this way this problem was asked in exam and we can find all the values. Next is the problems are based on the problem is based on the cross correlation. So what is cross correlation? Cross correlation means the measure of similarity between the two completely different signals. Cross correlation is the measure of similarity between two completely different signals. So we have seen all these properties, and now the next is a problem based on this cross relation. We have to find its value. Right here, find cross correlation between the signals. So what is given? X of t is equal to 4 e raised to minus 5t u of t, and y of t is equal to 10 e raised to minus 10t u of t. So sketch the cross correlation. This problem was asked. This problem was also asked in exam. So next is here solution we will see. So r12 of tau, it is equal to integration minus infinity to infinity x of t into y of t minus tau dt. So now y of t minus tau, it is 10 e raised to minus 10 t minus tau u of t minus tau. So 10 e raised to minus 10t into e raised to minus becomes plus 10 tau into u of t minus tau. Therefore r12 of tau, it is equal to integration minus infinity to infinity 4 e raised to minus 5t u of t 10 e raised to minus 10t e raised to 10 tau into u of t minus tau dt. So 10 into 4, 40 is constant taken outside the integration e raised to 10 t integration minus infinity to infinity integration minus infinity to e raised to minus 10 plus minus 10 minus 5 is minus 15t u of t minus tau dt. So 40 e raised to 10t integration infinity e raised to minus 15t dt. Now 40 e raised to minus 15t by minus 15, it is tau to infinity. Okay, it is e raised to tau. Okay, so now we solve this. 40 divided by minus 15, so it is minus 2.67 e raised to 10 tau, as it is e raised to minus 15 t. Integration goes from tau to infinity, so it is minus 2.67 e raised to 10, 0 minus e raised to minus 15. So by solving we get the answer minus 2.67 e raised to minus 5 tau. So now next problem. Find the autocorrelation of following signal. Find the autocorrelation of following signals. So first signal is x1 of n is 4 3 2 1, and second is x2 of n is u of n, u of n. Now first we write down x1 of n is equal to 4 3 2 1. It is given. So we have standard equation. So first we write down this. R of k is equal to summation n goes from minus infinity to infinity x1 of n into x2 of n minus k. So for k is equal to plus minus 4, there will be no overlap. There will be no overlap in between x1 of n and x2 of n minus 4. So now in that duration the product is 0. So we write here. So in that duration, as there is no overlap, in that duration the product is equal to 0. So the range will be, what is the range? It is minus 3 is then equal to plus. It is in between minus 3 and plus 3. So now we write down r of minus 3 is equal to summation n goes from infinity minus infinity to plus infinity x1 of n plus 3. So we expand this summation. It is x1 of minus 1, x1 of 2 plus x1 of 0, x1 of 3 plus x1 of 1, x1 of 4 plus x1 of 2, x1 of 5. Now we have to write the values here. So r of minus 3 is equal to x1 of minus 1, it is 4 into 1 plus 3 into 0. We have the values of x1, that is 4, 3, 2, 1. These values are given. Okay, this is x of 0, x of 1, 2 and 3. As arrow is given here, it is x1 of 0. So plus x1 of 1 is 2. 0 plus 1 into 0. We write here r of minus 3 is equal to x1 of minus 1 is not here, x1 of minus 1 is not here, so it is 0 into x1 of 2 is what? This is 0, 1, 2, 3. Okay, these values of x1 of 0, x1 of 1, 2 and 3. So x1 of 2 is what? 2, so it is 2 plus x1 of 0 into x1 of 3, x1 of 0, 4 into 1 plus x1 of 1 is what? 3 into x1 of 4 is not present, so it is 0 plus x1 of 2 is what? 2 into x1 of 5 is not present, it is 0. So here 0 plus 4 plus 3, 0 plus 0, answer is 4. Okay, now also we have to find r of minus 2. So here summation goes from n is equal to minus infinity to plus infinity, x1 of n, x1 of n plus 2. So we write here x1 of minus 1, x1 of 1 plus x1 0 x1 0, x1 of 2 plus x1 1, x2 1 plus 2 is 3 plus x2 2 plus 2 is 4, x2 of 2, x1 of 2 into into x1 of 2 plus 2 is 4. So what is x1 of minus 1? It is so what is x1 of minus 1? It is 0. x1 1 is 3 plus x1 0 is 4 into x1 2 is 2 plus x1 of 1 is what? It is 3 into x1 of 3 is 1 plus x1 of 2 is 2 into 0. So it becomes 0 plus 8 plus 3 plus 0. So it is 11. Now we have to find r of minus 1. So r of minus 1 summation n equal to minus infinity to infinity x1 of n plus 1. So here x1 of minus 1 into x1 of minus 1 plus 1 is 0. Okay, plus x1 of 0 into x1 of 0 plus 1 is 1 plus x1 of 1 plus 1 is 2 plus x1 of 2 x1 of 2 plus 1 is 3. Okay, so what is the value of x1 of minus 1? x1 of minus 1 is 0, so 0 into x1 of 0 is 4, 0 into 4 is 0 plus x1 of 0 is 4 into x1 of 1 is 3, it is 12. Okay, plus x1 of 1 is what? It is 3. x1 of 2 is what? 2. So 3 into 2 is 6 plus x1 of 2 is what? 2. x1 of 3 is 1. So 2 into 1 is 2. So this value is 12 plus 6, 18 plus 2 is 20. So in this way we can find the values. Okay. Now next is we have to find r of 0 now. So r of 0 is equal to summation n goes from minus infinity to infinity x1 n into x1 of n. So here we write x1 of minus 1 into x1 of minus 1, here both n, plus x1 of 0 into x1 of 0 plus x1 of 1 plus x2 of 1 into x2 of 1. So what is the value of x1 of minus 1? This value is 0 into 0, so it is 0 plus this value is 4 into 4 is 16 plus 3 into 3 is 9 plus 2 into 2 is 4. Wait, to consider this one also. So and last one is x2 of 3 into x1 of 3 into x1 of 3. So it becomes 1 into 1 is, so it is 16 plus 4, 20 plus 10 is 30. Now we have to find r1 also. So r1 summation n goes from minus infinity to infinity x1 of n into x1 of n minus 1. So we write here x1 of minus 1, x1 of minus 1 is minus 2, x1 of 0, 0 minus 1 is minus 1 plus x1 of 1 minus 1 is 0 plus x1 of 2 minus 1 is 1. So here minus this value 0, the x1 of 0 is 4 into 0 plus x1 of 1, 4 into 3 is 12 plus x2 of 2, 6 plus we have to write here x1 of 3 into x1 of 3 minus 1 is 2, so it is x1 of 3 is 1 into 2, so it is 2. So this value is 10 plus 2 is 20. Similarly, we can find the value r2. Here I directly write the answer, and r3, so it is 4. So here I write rk. So r of k is equal to 4, 11, 20, 30, 20, 11 and 4. Now here r of 0 value is 30. So this is here r of minus 1, minus 2, minus 3, and here r of plus 1, plus 2, plus 3. Now we have to plot for r of k. So we plot here plot of r of k. So plot for this rk is, it is k, it is r of k, so it is 0, 1, 2, 3, it is minus 1, minus 2 and minus 3. For 0 value is 30, for 1 it is 20, For minus 1 also it is 20. So here we show it 20. Okay, for r of 2 it is 11 11. So here we show 11. Similarly here 11. R of 3 or r of minus 3 it is 4. So here we show 4. It is 4. So in this way we can draw the graph of r of k. Next we have to find the x2 of n equal to u of n. We have to find the autocorrelation of x2 of n and u of n. So here I write down x2 of n is equal to u of n. So r of k is equal to summation n goes from minus infinity to infinity x2 of n minus k. So some n goes from minus infinity to infinity u of n minus k. Now for u of n the limits will be from 0 to infinity. For k it is from minus infinity to infinity. So there won't be a changes in rk in spite of the overlapping changing as un and u of n minus k are infinite. So we write here for u of n the limits will be from 0 to infinity, and for k limits from minus infinity to plus infinity. So there won't be a changes in r of k in spite of the overlapping changing as u of n and u of n minus k are infinite. So r of k is constant, not having a finite value. We write here, so r of k is constant, not having a finite value. Okay, so this problem was asked in exam for 8 marks. So in this way we have to find the autocorrelation. For that we have to find the different values within the range. That is here we find the r of minus 3, r of minus 2, minus 1, 0, 1, 2 and 3. Then we plot the graph for this. For that we use a summation equation, standard equation. Next problem is also based on the cross correlation. So we have to find the cross correlation of the given sequences.